Okay. This one, let's say you did use Lhopitals. Then the derivative of sine will be cosine. And the derivative of x would be 1. And the derivative of pi is 0 because it's a constant. So you just get 1. And you take limit x going to infinity. What's this limit? How does the cosine graph look like?
It never goes higher than 1, right?
Yeah, so what?
It'll be in the term.
It will not exist.
Right.
Yeah, that's what I know.
Yeah, the limit won't exist because it doesn't get close to single value. It just fluctuates forever. So that limit doesn't exist. Okay. However, this is the wrong answer. Why?
Because man,
Because
It's too easy.
that's too easy. Okay. Well, yeah, that too. I mean, I wouldn't put it on a practice exam if it was too easy.
Because there is a limit because it doesn't exceed 1. Like,
Okay. But what did I do wrong? I did some math and I got some. Yeah.
When it's pi, it's the bottom 0.
Oh no, that's okay. All right, so that's a good point. When x becomes pi, the bottom 0, but x extends to infinity, so x will be much bigger than pi. Okay. Yeah.
wouldn't it be infinity over infinity type?
It wouldn't be. Why?
Wouldn't?
What's sine infinity?
Sine infinity would be 0, right?
No.
Not determined.
Sine is again.
Uh,
So this does not exist.
it's never supposed to be.
So it's like you have something on top that does not exist. On the bottom it goes to infinity. Now is this one of the cases where you can use Lhopitals?
No. So we could rewrite
So what was wrong when I did the previous calculation?
you did Lhopitals.
I used Lhopitals. I'm not supposed to do that. We can't use Lhopitals. Because it's not of the form infinity or 0 over 0. Therefore, we can't use Lhopitals. This is a question that has to be determined without using Lhopitals. So how do you do that? Well,
Squeeze.
no. You start with the fact that sine. Oh, let's see. This. You start with the fact that sine is less than 1, and it's bigger than negative. Sometimes that can be equal, so I put equal signs here. That you all agree, right? Sine fluctuates between 1 and negative 1. And therefore, if I divide all of these by x minus pi, and while dividing by a negative number requires flipping the inequality because we are sending x to infinity, x would be a very big number. So we're really dividing by a positive number. So there is no need to flip the inequalities. This inequality will be preserved. And then what we say is that if I take limit x going to infinity, then this inequality will still be preserved. That's called the squeeze theorem. But what is this limit? If you divide 1
0.
by infinity, you get?
0.
What is this limit?
Negative 0.
Which negative 0, which is 0, right?
Doesn't exist.
Now the squeeze theorem is actually slightly more. Even if this was a strict inequality, the limit could be equal. So that's one of the squeeze theorem. But anyways, that's what we have. Now look, what does this force this thing to be equal to?
0.
Because what's a number that's less or equal to 0 and bigger than bigger or equal to 0. Must be 0, right? So this has to be 0. Yeah.
Did we learn how to do this?
No, but now you see it, so now you know.
Are you gonna put this on the down?
Yeah, maybe.
I have a question.
Yes. What's your question? Oh, keep thinking about the question.
Yeah, because
Why?
how would it be, what if we had, never mind, no, because it's negative. And then, what would it look for the cosine then?
If I replace the sine by cosine, it will still be 0.
Because cosine fluctuates.
Cosine is also between 1 and negative 1, so same logic applies.
What kind of questions would you use to squeeze theorem for? Just like trig ones?
Yeah, usually trig. You limit the trig between two values and then you just send it. But
Could it be any two values? Like you could have done that with 1. You could have done that with.
well, you can say
0.
sine x is less than 2 and bigger than negative 2. And
As long
you
as
can
they
still-
stay the same
yeah, still
value,
the
just-
two sides will become 0 and then you have the thing in the middle will become 0.
Oh, okay.
However, let's also think about the following question. Can we just determine that that's 0 without using the squeeze theorem? Does it make sense that this limit is 0?
Yeah.
Why? Why does it make sense?
Because
It doesn't?
Because if it's 0 on top, then technically it could be and
No. Look
I just don't get
at
how you can.
just plug in something like million. What happens? What's sine of million?
It's not
0.
Does it exist?
It's some value between negative 1 and 1, right?
Oh.
Sine of million is some value between
But the bottom value is
Oh, so
Well,
it's
you're
always gonna be
dividing
1
that
over
by
divided
a million. Million minus pi is about a million, right? So what's happening?
The bottom-
It's
the
getting
The
closer
bottom
to
is really
0.
big and the top stays about the same. So if you divide, what happens to the value?
It gets closer to 0.
It will get closer and closer to 0.
Wouldn't
So
that
we
be
don't
the
have
same
a
for
calculator.
cosine too?
You don't need a calculator to be convinced. We can just do the same thing. Yeah. Yes?
That would be the same thing for the cosine.
That would be the same thing for the cosine as well, right?
Because you're saying.
Cosine is still between negative 1 and 1, so if you plug in a million,
Oh.
you get some value between negative and 1 and 1 divided by a million. That's a very small number.
So-
Yes?
So what you're telling me is if I see cosine or sine on the exam with a limit of
No.
of infinity, then
I
I'm just
refuse
gonna
to
write
say
0.
blanket
I'm just gonna write
statements
0.
like that. No. I refuse to make any blanket statements.
That's weird. What about
Good for you.
tan then?
Hmm?
What about tan? Isn't tan like above cosine and all that?
Tangent goes to infinity, right? So if that was like tangent x over x minus pi,
Oh, I mean like the range of tan. What is that? Because
tangent goes to infinity.
Oh, really?
Tangent graphs like that, right?
Oh, I must be thinking of something else then.
Yeah.
Oh, I think when you like minus 1 outside and like it brings it up.
No.
Like how you move it on the graph for sine.
I don't think we want to go there.
Oh, okay.
Okay, yeah. All right. Stop giving me ideas.
Oh, yeah, relax.
I might have great ideas after your suggestions.
Ah.
Okay. All right.
Yeah, good job.
Next, you have an exponential form of this part, right? A to some power of b. How do you solve such a thing? Well, first of all, this is about whether or not to use Lhopitals, but this is not in a fraction form. So what do?
Make it
Force it into a fraction
Yeah,
form,
you
raise
make
it
it
to
as a
ln.
fraction by using exponents and ln, right? So you raise everything over e with ln of 1 minus sine x, 1 over x. And these two things are the same because e and ln cancel, right? Ln and e cancel, so if you do cancel them, you get the same thing. So I'm just rewriting this in a more complicated form. Why do I want to do that? Well, because then this 1 over x can jump over the log. What's that called?
Frog over log.
Frog over the log rule. I should copyright that terminology. Okay, and therefore you have e of 1 over x times ln, 1 minus sine x. Now, look, e doesn't change, right? It's really this one that changes. So this limit can be just obtained as e of limit. And we can rewrite this as when you multiply this to 1, you get ln of 1 minus sine x on top and x on the bottom, with limit x going to 0 plus. Okay, now let's look what this is like. Sine of 0 is?
0.
0. So when 0 is plugged into sine, you get 0 and you get ln of 1. What's ln of 1?
0.
It's also 0. And then when 0 is plugged into x, you get 0.
type.
So this is 0 over 0 type. Which means we can use Lhopitals. We are allowed to use Lhopitals. So
If
if
you get a
e,
fraction of,
when you get what?
because when you take the derivative of ln, when you get like a fraction,
Yeah, you will again get a fraction. Yes. So because ln of x differentiates to 1 over x, differentiating this will give you 1 over 1 minus sine x.
Times.
Whereas you still have to use times of what? The derivative of the inside function. It's a chain rule. If you differentiate 1, it's 0. If you differentiate sine, you get cosine, so it's negative cosine. Divided by derivative of x is?
oh, 1.
Wait, why do you get negative
I have a
cosine? Is that
question.
because of the derivative?
No, it's
Yeah,
derivative
the
of
chain
ln.
rule. Chain rule, yeah.
So at this point, can you just like do away with that 1 and just treat the numerator as its own fraction?
Yeah,
Like,
that's what it is, right? Yeah, dividing by 1
So
doesn't
you
do
just
anything,
equal
so it's
negative
really
1.
this one.
okay.
Now you plug in 0. What's sine of 0?
0.
Cosine of 0?
Negative.
1.
It would be
Yeah,
negative 1.
so you can evaluate it, right? Let's actually evaluate it. It's going to be 1 over 1 minus 0 times negative 1. That's just 1. 1 times negative 1 is negative 1, which is same as 1 over e. So either one will be correct. You can just write it as e to the negative 1, or you can write it as 1 over e.
I just noticed that sometimes I felt like you were evaluating it with that 1 still in the denominator. Maybe I'm remembering this incorrectly, but I don't know. I was like, do I have to hold on to that 1 when I
No, dividing by
evaluate
1
it?
doesn't do anything.
Right,
Yeah.
right. So I
that's
just
right.
didn't. Okay.